What we want to talk about today is the case around mission-critical cooling in data centers and how obviously this industry starts to transform and finds itself at a pivotal point. To the right of me is Freda, an industry veteran of the data center industry, more than 20 years of experience. Myself, I'm Hary. I'm leading our industrial and infrastructure flow solutions. And very excited to have you here obviously today. Let me start quickly by putting this data center opportunity a little bit into perspective of the overall industrial flow solutions. What you can see on the industrial flow solutions, where we're engaging into, is various segments. And data centers is just one, very important, but only one of various advanced industrial segments we're working on. On the one hand side, we're working in semiconductors, microelectronics, which is a key segment for us. Data centers, we talk about chemical processing industries. Food and beverage, especially cold stores, but also process cooling plays a big role. The general industrial water industry. We talk about energy, not only renewable, but certainly also when it comes to energy transmissions, plays a big role. The marine business, cruise, but certainly also merchant. And lastly, we're talking also about the life science segment, which are key areas for our business on the industrial side. You see some of those very demanding customers. I guess most of them should be known to you. And in terms of offering, we're offering high engineered polymer solutions in terms of systems, solutions, including engineering, advanced engineering, and prefabrication to these challenging customers. Now, let me set a little bit the foundation, what we have done in the last strategy cycle, especially the last 3 years, in order to set the foundation to build upon. Firstly, we invested heavily to improve the proximity to these challenging customers around the world, especially when we talk about this microelectronic semiconductor business, when we talk about our marine opportunities, when we talk about data centers, as we will go a little bit deeper into now. But here what we did is, in terms of resourcing, technical application, and feet on the street, we invested heavily in the last few years to make sure we are closer to maintain, gain, share of wallet and market shares. We built up a global fabrication network, not only for prefabrication, close to turnkey solutions, also in terms of our advanced engineering offering. We have a global network which we offer our customers pretty much with the same offering and delivery, pretty much from the West Coast out of the US all the way to Taiwan. And lastly, we established with key customers, end customers, water OEM and contractors. This, for example, is Gradient, but also Veolia and others, key account relationships to make sure we're very early on in projects to win and differentiate. And this foundation we want to use now, going forward, to drive growth in key industrial segments going forward. And to make it simple, what we're trying to do is we try follow the money strategy here. We're trying to select exactly the segments which outgrow and where we can differentiate against competitors to win market share and share of wallet. Again, semiconductor, data centers, marine. We're talking about high voltage direct current transmission lines, areas like this where we see significant potential and higher growth rates. We want to be considered as the partner of choice by being very easy to work with, very easy to deal with by the offering, the way how we bring our solutions to the customers, and providing at the end peace of mind for these very critical industries to make sure these processes are running seamless without any faults. And lastly, when it comes to the innovation, our innovations are nicely aligned exactly with the segments we want to go into. You see, for example, the jointing machines we just released this year in the back, for example, to make sure not only the contracting and the construction process is perfect, but also the solutions in terms of systems deliver the performance for these industries as required to differentiate again. And to summarize the strategy, 2030, on the one hand side, again, Max the Core plays such an important role, and the excellence in execution is key. So we want to perceive as and realize the vision to be the service leader in this industry, following again these high growing segments. In terms of new opportunities, We talk today about data center as one of the key opportunities, but there's more. There's also marine moving from Europe to Far East, where we want to play a big role. We have different critical elements, like, for example, metal refining, HVDC, and so forth, I mentioned, and all of this supported by the right targeted innovations for these application and critical customers to differentiate. And lastly, what is very important, we want to make sure that we have the sufficient investments into scale and the skill of our technical application and salespeople in the markets to make sure to differentiate, be early in the projects, and win. Now let us dive a little bit into the data centers. Overall data... Thank you. Let us dive into data centers. First of all, I think you all know it. Overall, this investment into data centers, with the AI boom ongoing, but even without the AI boom, the digitalization, right? We see overall this growth trend of over 20% CAGR in the years to come until 2030. Key is that when I talk about AI, the energy density those chips need is significant and traditional solutions don't work. And here we see this tipping point of a significant growth rate of roughly 40% CAGR in the years to come. And this is exactly one of the areas. We see the air cooling as super interesting and attractive, but it's mainly the liquid cooling side where growth rates will be staggering, and also the capital deployed with almost $1.7 trillion over the strategy cycle is a key area where we want and will take part of. If you think about the needs and the pains of these customers, we just take as a reference a 60 megawatt data center right now. And this, to be honest, if you put it in reference, is a mid-sized to large data center. It's not a campus. This is not a huge data center. It's a mid-sized data center. We're talking about capital investment just for infrastructure of roughly $700 million. We're talking about energy. Energy is pretty much the driving operating cost of a data center, 30 million plus, just in terms of the energy requirements. Sometimes also energy availability plays a big role. And last but not least, and this is key, reliability of service. So the service level agreements, the SLAs in place with some of those customers are currently right now at 99.995 for some of those key customers, and it's moving into 99.999. So reliability, the energy efficiency of the cooling solutions, but certainly also speed and reliability and execution of construction plays a key role. And these are all areas, obviously, which we try to address and make use in terms of a positive differentiation. And there's a second point, and the second point is the usage and the need for water. Now, there's always usually water enough there, but usually not at the right spot. And that's exactly what's happening with data centers. Data centers are usually built in areas, subsidies behind it, where water is scarce. So that means from an overuse situation, it yields as well potentials for a company like GF with its solutions to also go into the reuse field. Not only the process cooling, but certainly also the infrastructure opportunities around data centers is quite significant for us. Why is GF well positioned? GF is well positioned because we have more than 30 years extensive experience, especially in the semicon microelectronics industry when it comes to ultra pure water applications. Several years, various awards from some of the key customers in this industry. So that's one of the things, but certainly also by now we have more than 20 years and over 150 reference projects in the data center space. So in terms of contacts to contractors and customers in this whole ecosystem, the whole digital world is not unknown to us, but also especially around the data center world, we do have quite a vast experience and background. Let me quickly close before I hand over to Charles Freda with where are the opportunities. First of all, and you will see this afterwards in the showcase on the infrastructure side, or you probably have seen, you will see this. On the one hand side, there's infrastructure solutions, stormwater. It's about the water reuse, the water retention tanks, which we can offer as turnkey solutions. We're talking about the facility cooling options and opportunities, which we have traditionally done for air cooling and facility cooling. And now we see the pivotal point when it comes to the technology cooling and the direct-to-chip cooling that Charles will allude to a little bit more. There's a fourth point we don't mention here. Usually, if you have a huge campus of data centers, there's also a lot of employees around. And employees need employee space. And obviously here also, when you think about what we can offer from building flow solutions in key projects, from heating, cooling, but certainly also sanitary, there's also options we can certainly think about for the future when we talk major projects. So really tying together infrastructure, the building flow, but certainly also the industrial side. And with this, I would hand over to Charles to give us more insights on the data centers.
Thank you, Thomas. And a warm welcome from my side. Thanks for joining us. You'll hear from me again this afternoon during lunch, so I will dive deep into the liquid cooling topic. We'll start to touch it here. Ultimately, as Thomas alluded to, we've got three main routes to win business in the data center world. We've got the infrastructure business, which you'll see momentarily. We've got traditionally what we've been heavy into for many, many years. We say over 150 projects, but it's way more than that around the world. And that's the traditional, what now the industry is calling facility water systems. That's chilled water, condenser water, the things we see outside of the building that feed services inside the building that are critical cooling, but they're nowhere near as exotic nor new as the technologies that we're playing for right now. Ultimately, our value proposition is one in which it plays to the strength of polymers, it plays to the strength of GF and what we've been doing for years. So on the facility water side and the technology water side, it's ultimately nothing particularly new from a reliability standpoint, from a corrosion-free operation standpoint, maintenance standpoint. Insular performance, we say from 6 months to 6 weeks with prefabrication. That's not a GF claim. That's from one of the largest general contractors in Europe with regard to a hyperscale project outside of Dublin. That's a case study that we can share with you. But ultimately, we have a distinct advantage in the polymer solution. Historically, as Thomas alluded to, in one way, shape, or form, whether it had a coil and water on it or not, the data center always had air cooling. And that was with the crack or crawl gallery kind of feeding to a cold aisle. And then that cold aisle would pull the air through the front of the server. Small fans would eject it out the rear of the server, go to the hot aisle, come back, repeat the process over and over and over again. That's still there. That still will be there for a long time to come because you're always going to have some degree of humidity control. You're going to have to remove latent heat. You're going to have to be able to have some degree of air movement for human workers in the space. There aren't as many in the data center as there used to be with a lot of automation, including robots for racking and stacking. However, there still will always be a component of air and devices that won't be air cooled. That said, the tectonic shift in this industry has been to liquid cooling. There's two main flavors. There are sub-variants therein, but there's direct-to-chip, often called DLC, which is direct liquid cooling as we call it here. That's what we're putting our big focus on because it plays to our strengths and it plays to our history, specifically in the microelectronics business, but other businesses as well, labs, validated pharma, so on and so forth. There's also immersion cooling. We don't touch on that as much at scale. Immersion cooling, it's a great way to have heat transfer, but at scale it just doesn't work as well for the hyperscale neocloud operators for a number of reasons, ranging from floor loading to EH&S concerns. We've talked about the growth, but look at the hockey stick curve for liquid cooling, and those are obviously not our numbers. So that's where we're doubling down on our bets, and ultimately coming up with a line of really innovative products and solutions that build an entire system that offer our clients a clean, pure, reliable, lightweight, and quasi-sustainable solution for liquid cooling. When we talk about liquid cooling, fluids are a much better thermal conductor than air. That's why, as we get to this 95 kilowatts per rack seems to be about the breaking point where laws of physics start to apply and exude their force. So basically, we can no longer take that cold air through the front of the server, exhaust it out the back, and get enough heat rejection to cool these new chips that are super power hungry and super powerful, whether that's GPUs, TPUs, or in some cases CPU, as the case may be. Today, we'll talk about this a lot more this afternoon, but kind of the dominant liquid of choice is a water treatment mixed with a 25% propylene glycol solution. We believe that in the not too distant future, we're going to see a significant shift towards DI water, deionized water. Again, that works advantage polymer and advantage GF for our exhaustive experience with that media inside of not only the microelectronics business, but other validated work as well. And ultimately, that will be better for not blocking the channels. When we look at a liquid cooling system, specifically direct to chip, we have here represented our CDU, or coolant distribution unit, which takes that facility water, chilled water, condenser water on the primary. There's a heat exchanger therein. Perhaps I'll come over here and sorry to the cameraman, but start to talk about here. So our CDU is not pictured. However, then we come to a header. We have to distribute that fluid. This is in our DNA today. We manufacture manifolds in multiple materials every day for years and years and years, repeatedly, reliably around the world. Put it into a specific material, come to our next innovation, which we'll speak to in a moment, generally to a hose and then to a rack manifold, from the rack manifold to other hoses, and then on to the cold plates that these chips sit upon. We are uniquely positioned from not only a polymer manufacturer, but any mechanical system manufacturer to have a solution for virtually every piece of this puzzle and other facets that we'll talk about more this afternoon, like the OEM play, or perhaps on the server tray. When you couple that product mix with our ability to have that sun-up to sundown engineering services, prefabrication, the reliability of our welding, 1 in every 3 million infrared welds will fail. That's a pretty good number, especially relative to steel. So what have we done to really get after this market? Well, we've been in the data center business for some time. However, liquid cooling has always been a few years away. Well, that few years is now, and that pace is, I mean, look at just NVIDIA, look at one chip manufacturer, and look where they've gone in their generations of super GPUs already. We'll talk more about that this afternoon. There is one major manufacturer that makes a large quick connect valve, which allows you to, quote unquote, rack and stack, and ability to perform an IT refresh on the fly. So we have devised a solution. There is one dominant manufacturer, so we didn't come up with a Me Too product. We came up with some really innovative, ultra pure means with which to connect and disconnect the racks, as well as a tremendously innovative solution as well for the granular control at the rack level. But we didn't create a Me Too, we created a better solution. Less weight, higher purity, ergonomic operation. More importantly, better flow. We're a flow systems company. We talked about that a lot. We'll continue to talk about that. We manufacture millions of ball valves a year in our Sabies facility. By utilizing that know-how and using full bore ball valve technology, we're able to squeeze a lot more out of a smaller, lower weight product. At the same time, we have new innovations coming to market that aren't even out yet, but we showcase them here, where we're looking at how can we granularly control the thermal mass that is coming to this cold plate that these CPUs, GPUs, DPUs, and TPUs all sit upon, and how can we control that and be a better part of that value creation stream. Works for other industries as well. We're very, very excited about this valve that allows us granular control based on actual demand. Okay? This business is not for the faint of heart and is a long play. So even though technology moves quite quickly, as we well know, we don't just show up and say, hey, we're GF, look at my suite of thermopolymer solutions, and let's go. How much can we sell you today? It doesn't quite work like that. So here we showcase a couple of our, these are both Asia focused because we can speak to both of these, but it's a proof of concept. It's a show me business where oftentimes by NDA, MSA, ISA, and others, but intellectual property agreements, we can't often show what we're working on. In this particular case, we can. With the National University of Singapore, we've got a fully deployed liquid-cooled system of polymers from the FWS, that primary water side, to the technology cooling loop. And here with many OEMs and Magnificent 7 operators, we have proofs of concept that are being deployed right now with our products and services, and they're proving out very well. And at the same time, we of course have our own lab testing. So proofs of concept are key, and we have more than 17 deployed today around the world, not to mention what we're doing at production scale. So we see the trend toward liquid cooling. Everybody sees the trend toward liquid cooling. GPUs, AI are driving that, but we're responding to it and trying to stay as far ahead of it as we possibly can, and also thinking ahead towards microfluidics, quantum compute, and so on and so forth. With that, we'll wet your whistle with the primer and do a deeper dive this afternoon and open it up to any questions.